Hello everyone. In this session, we will understand the criteria of selection of a circuit breaker type and the suitable size to withstand our loads. Let's begin with introducing different types of circuit breakers. But first, what is a circuit breaker? It is an automatically operated electrical switch designed to protect an electric circuit from damage caused by excess current that can be a result from an overload or a short circuit. These circuit breakers are made or manufactured in varying sizes. It could be a circuit breaker that protects low current circuits or appliances up to large switch gears that can protect high voltage circuits feeding an entire city. Circuit breakers can be classified in different bases, including their type of rated voltage. Accordingly, we have low voltage circuit breakers category, which is what we are going to emphasize on in this session, and also medium and high voltage category. So what are the types of circuit breakers that are used in low voltage systems? Well, there are three types of circuit breakers that includes miniature circuit breaker or MCB, molded case circuit breaker or what is known as MCCB, and air circuit breaker or what is also known as ACB. Although our main aim in this session is to focus on low voltage types of circuit breakers, we can also have an idea about medium and high voltage types of circuit breakers that includes oil circuit breaker or OCBs, which is now replaced by air circuit breaker because of its higher risk to ignite fire. So nowadays, oil circuit breakers are rarely used. Another type is the vacuum circuit breaker or the VCB. Third type is the sulfur hexafluoride circuit breaker, which is known as SF6. And also air circuit breaker is used in medium voltage systems. Now let's indulge into more details about each type of low voltage circuit breaker and understand each of their characteristics. So starting with the miniature circuit breaker, we can say that these are the breakers used for our home appliances. If you open your DB or distribution panel located at your home, you will see this type of circuit breaker. It protects sockets, lights, cookers, washing machines, air conditioners, and other appliances. It can be of a type of 1, 2, 3, or 4 pole type according to the phases that it feeds or protects. They mainly protect circuits from overload and short circuit cases. The current rating of this type of circuit breaker starts from 5 or some manufacturers manufacture 6 amperes going to 125 amps. So all these ratings are available in the market between 5 ampere to 125 amps. This is how a miniature circuit breaker looks like. The first here is a 3-pole or 3-phase circuit breaker. It protects 3-phase appliances or loads, and the other is used for single-phase loads. These circuit breakers have 3 types. These types are B, C, and D. Type B trips at a rate of 3 to 5 times its rated current, whereas type C trips at a rate of 5 to 10 times its rated current, and type D, which trips at a rate of 10 to 20 times its rated current. So on the type of the load that we are going to connect, we are going to select among these types. For example, if we have a motor load, we are going to select type C or type D, and this is because motor loads have high inrush currents. Also, circuit breakers has short circuit protection ratings in kiloamps. If we zoom in at these circuit breakers, we can observe that this is a C-type circuit breaker with 16 ampere rating, and also there's a number below here. It's a little bit blurred, but this number is 6000, which indicates that this is the short circuit protection for this circuit breaker. So the maximum number or rating of short circuit this circuit breaker can withstand is 6,000 amperes. The selection of a suitable circuit breaker rating, including short circuit, should be done in accordance with the standards, country codes, and should be also based on calculations. Now let's put this into context and understand further the B, C, and D types of miniature circuit breakers by looking at their different graphs. So here we have three graphs. Each graph represents the type of the circuit breaker. We have type B, C, and D. Let's first understand the x-axis and the y-axis of each graph. The x-axis represents the multiplication of the rating of the breaker, while the y-axis indicates the tripping time or the time the breaker will take until it trips. Let's take an example that we have a C-type, or we selected a C-type of circuit breaker, and this breaker is connected to an air conditioner, let's say. Let's select a darker color. So we selected a 20 ampere of circuit breaker, C-type, and we wanted to know the tripping time of this breaker or the characteristics of this breaker. We can go and refer to the graph of the C-type, and let's assume that we had an overload of 5 times its rated current, which is going to equal 100 amperes. So 5 times its rated current lies in here in this graph. If we go up all the way and then look in here, ignore this bit, we will notice that the tripping time of the breaker when it reaches 100 amps is approximately 7 seconds. So now we understood that after 7 seconds, the breaker will trip if it reached 100 amps. So why do we need to understand these curves? Well, sometimes we connect the circuit breaker to a motor load, let's say an air conditioner. In our case, if the air conditioner, usually the air conditioners has got inrush currents, which is a spike in the current at the start when you start the load, and this starting current is very healthy. We don't really need to interrupt that spike. So we will select a breaker, either a C-type or a D-type. And that is because it gives us a delay in time. The inrush current might be 2 times its rated current, let's say. And if in our example, it's 40 amps, so it reached 40 amps, it's going to be here. And that gives the breaker around maybe 50 seconds, 40 seconds to trip. So usually inrush currents do not take that much of time to trip. So this means that C-type is the best type of circuit breaker that we can select for a motor load, and so on. So we can understand from the characteristics of each graph how or when the circuit breaker will trip in accordance with its rise of current. So the higher the current, the less time it's going to take to trip the breaker. Now let's have a look at this merged graph. It shows all types. We have already looked at B, we looked at C, and we looked at D. We have here Z and K, which we will take in the next slides. We will understand these types because these are molded case circuit breakers, but the concept is exactly the same. Type Z trips 2 to 3 times its rated current, while K trips 10 to 12 times its rated current. We can understand from the graph that the more overload or short circuit, or the more multiplication of the I rated current of the breaker, the less time it's going to take to trip the breaker. Now, looking at these two photos, we can observe that these miniature circuit breakers protect several loads. Each of these circuit breaker has its own rating, its own type, and also its rating of short circuit that it can withstand. And this is how a distribution board looks like after it's covered. The second type of low voltage circuit breaker is the molded case circuit breaker. They also perform the same function as a miniature circuit breaker by protecting circuits from overload and short circuits. However, this type of a circuit breaker can carry and protect higher current loads than a miniature circuit breaker. This type of a circuit breaker has current ratings from 40 ampere up to 3200 amperes. But keep in mind that loads that are higher than 630 amperes are advised to be protected by air circuit breakers, and that is according to different wiring codes. Looking at Qatar's wiring code, for example, going at the submains section, this clause states that current rating above 630 ampere shall be protected by air circuit breaker. This means that if the current rating exceeds 630, it is advised to be protected by an air circuit breaker instead of molded case circuit breaker. A molded case circuit breaker looks like this. It has 5 types. The 3 types are the same as the miniature, B, C, and D, but it has also additional 2 types. Type K trips between 8 and 12 times its rated current, while Type Z trips between 2 and 3 times its rated current, but it has higher sensitivity to short circuits. So based on the nature of the load connected, we will select a suitable type. Also, molded case circuit breakers can have current rating setting that can be adjusted manually. So if we zoom in at this photo here, we can spot the setting option that we can adjust manually. We mainly are going to find this type of circuit breaker installed for submain loads or at submain distribution boards. Now, these are 2 real photos of molded case circuit breakers. First photo shows a molded case circuit breaker installed at a main distribution panel. And of course, a molded case circuit breaker does not look like this. This is just a lock or a rotary handle. It's just an accessory for a molded case circuit breaker. If we open this door, inside this door, we will find the known shape of a molded case circuit breaker. The other photo shows a sub-main distribution panel which feeds and protects different loads that includes lifts. Each of these lifts are protected by a molded case circuit breaker. Now moving to the third type of low voltage circuit breaker, we have the air circuit breaker or ACB, which can withstand higher loads than a molded case circuit breaker. It can withstand up to 6,300 amperes. They also protect circuits from overload and short circuits. As an additional preference, air circuit breakers tripping thresholds and delays are adjustable. We mainly are going to see such a type of circuit breaker used at the upstream end of the circuit, in most cases at the main distribution panel board. This is how an air circuit breaker looks like. As you can see, it is bigger in size and it's more complex than miniature circuit breaker and molded case circuit breaker. Air circuit breaker current ratings start from 800 up to 6,300 amperes. Types of air circuit breakers include air blast circuit breaker, which is used for high voltages up to 245 kilovolts and even more. Plain air circuit breaker, which is used for low power circuits and up to 500 volts. Magnetic blowout air circuit breaker, which is used in voltage capacity up to 11 kilovolts. And finally, air chute air circuit breaker, which is used for low and medium voltage systems. Now looking at side photos of installed air circuit breaker in a main distribution panel, we observe that it occupies larger space compared with MCB and MCCB. Also, this is a withdrawable type that can be taken out easily for maintenance purposes. This air circuit breaker current rating is 1600 amperes, which is protecting an entire project. Actually, this ACB is directly installed at the upstream end of the circuit just after the secondary side of a transformer. There is also another circuit breaker type which performs different function than the previous types of circuit breakers. This type is called Residual Current Circuit Breaker, RCCB, or it could also be called Earth Leakage Circuit Breaker, ELCB, or also it could be called RCD, Residual Current Device. The main aim of this type is to protect circuits from earth leakage and electric shocks that may be caused by humans' direct contacts. They have different function than miniature circuit breaker, molded case circuit breaker, and air circuit breaker since it senses the earth leakage. Types of RCCB: the two-pole type, which protects single-phase loads, and the four-pole type, which protects three-phase loads. This picture shows the two different types of RCCB. The first is the two-pole type and the second is the four-pole type used to protect three-phase system. It trips the circuit when it senses earth fault or an imbalance in the live and neutral currents. There is also another advanced type of RCCB, which is the RCBO. It has an additional preference of protecting circuits from overload. So the O letter here indicates overload protection, in addition to the short circuit and earth leakage protection. Most widely used are the 30 mA, 60 mA, and 100 mA leakage sensitivity. This type of breaker is mainly used to protect appliances in wet areas like water heaters, water pumps, sockets inside toilets and kitchens. It could also be used for lights installed underwater, and etc. Briefly, let me explain how this circuit breaker works in simple words. Assume that an RCCB is protecting a water heater inside a toilet and this water heater's insulation of live wire is weak or is damaged. Then I accidentally touched the body of the water heater. At this time, the current will leak through my body, but also at the same time, the residual current circuit breaker will sense the imbalance between live and neutral, so it will immediately trip the breaker. And of course, all this happens in fraction of a second. So according to the sensitivity level of the RCCB, it will trip. For example, if this RCCB sensitivity level is 30 mA, then if a leakage reaches this level, it will automatically trip the breaker, saving my life and also saving the equipment. This is just a brief explanation of how the RCCB works during an insulation problem of a live conductor. Finally, let's summarize what we have taken so far. Low voltage circuit breakers include miniature circuit breakers, molded case circuit breakers, and air circuit breakers. Molded case circuit breakers and air circuit breakers have more preferences than a miniature circuit breaker, and as we said, the maximum current rating for a miniature circuit breaker is 125 amps. Residual current circuit breakers are used to protect circuits from earth leakage and are used for loads located at wet areas. Each of these circuit breakers has its own rated currents and short circuit that it can withstand. They all protect circuits from overloads and short circuits. And finally, all of these circuit breakers come in different types. Each of these circuit breaker has its own types. And according to our load, we are going to select among these types. I hope that the topic of types of circuit breakers is understood now, and I was able to conclude the types of circuit breakers in an easy way.